14:45 local time on June 27, 2025, a Ukrainian MiG-29 from the 40th Tactical Aviation Brigade sliced through the thickening clouds as it banked hard left. The pilot's eyes flicked rapidly over the cockpit instruments. Everything had been routine so far, but now his weapons interface exploded in sudden voltage warnings. His heart beat faster, the calm before the storm unraveling in an instant. What should have been a straightforward mission was about to spiral into one of the most technically demanding and dangerous strikes in Ukraine's air war against Russian drone manufacturing. The MiG's radar warning receiver screamed an alert. An S-300 acquisition radar had locked onto the jet from a staggering 95 kilometers away. Deep inside Russian-occupied territory, the pilot was now the hunted, diving aggressively to 500 feet altitude, leveraging the jagged terrain to mask his approach. Below, dense forests and rugged hills blurred past, providing fleeting shelter from the eyes of the sophisticated air defense network guarding the drone factory ahead. On board, the pilot's weapon systems ran through their startup sequences with robotic precision. 4 American-made GBU-39 small-diameter bombs lay strapped to improvised pylons, held in place by salvaged Soviet tank parts. A testament to Ukrainian battlefield ingenuity blending old and new. Each bomb's GPS receiver needed to lock on, its inertial navigation system calibrated and verified through the rigged interface. This process should have taken 30 seconds. 2 minutes later, tension tightened like a noose. Finally, at 14:48, the cockpit display flashed green across all 4 bombs. Target coordinates were locked in. A sprawling drone facility nestled 350 kilometers inside Russian-occupied territory. This factory produced nearly 40 Shahed 136 loitering munitions weekly, a relentless threat raining down devastation on Ukrainian soil. Intelligence reports confirmed a Kushuka 4 electronic warfare vehicle nearby, broadcasting 500 watts of powerful GPS jamming signals designed to blind incoming strikes. The pilot checked fuel reserves, 2,100 kilometers remaining, just enough to make the strike and get home safely. After weapons release, he'd have 18 minutes in hostile airspace before bingo fuel, forced to retreat. Outside, the S-300 radar's sweeping beam intensified, its lethal focus joined by a mobile SA-15 Tunguska system scanning from the southeast. In 6 minutes, the pilot would be forced to climb to 15,000 feet for weapons release, exposing himself fully to every air defense system in the sector. At that altitude, the GBU-39s could glide 110 kilometers toward their target, but only if their advanced guidance systems survived the intense electromagnetic interference cooked up by Russian jamming, interference that could fry ordinary electronics in seconds. Suddenly, a jarring voltage spike of 31 volts surged through the weapons system for 3 seconds before the onboard regulator kicked in. The improvised adapter pylons were pulling 32 amps through circuits designed for a maximum of 20. Somewhere in the tangled maze of wiring, Ukrainian battlefield engineers were locked in an invisible battle, fighting decades-old Soviet electrical standards to gain control over cutting-edge American technology. With throttles pushed forward, the MiG's twin RD-33 engines screamed to life, each pumping out 18,300 pounds of thrust. Crossing into contested airspace at 14:51, every threat receiver lit up simultaneously. S-400 radars from Melitopol tracking from the north, SA-15s vectoring in from the southeast, and the first creeping waves of Kushuka 4 GPS jamming bleeding across critical navigation frequencies. In 19 minutes, the pilot would discover if 4 precision weapons, jury-rigged to Soviet wings by Ukrainian ingenuity, could outsmart and survive the most sophisticated integrated air defense system outside Moscow. At 15:15, he banked right into an 8-kilometer gap, a narrow corridor between overlapping S-300 coverage zones carefully plotted by Ukrainian intelligence. For 7 agonizing minutes, the MiG would thread this needle, using terrain masking to avoid detection. This gap existed due to simple but unforgiving physics. The S-400 radar near Melitopol couldn't see below 800 feet at this range because of the Earth's curvature. The S-300 batteries were positioned to counter high-altitude threats, leaving deadly blind spots at extremely low levels. But precision was everything. Drift 2 kilometers left and the Western S-300 would catch him. 3 kilometers right and the mobile SA-15 patrol would be waiting. At 15:18, new radar signals lit up on the pilot's warning receiver. A mobile SA-15 had halted its movement, operators suspicious of the unexpected gap in their coverage. Their 9S-36 search radar began probing relentlessly, scanning for any sign of the intruder exploiting this weakness. The pilot reacted immediately, dropping to 400 feet above a dry riverbed, barely clearing power lines that had somehow escaped reconnaissance imagery. Every meter mattered. At 15:22, the moment came. The pilot pulled 4G, climbing aggressively to 15,000 feet, exactly when his radar warning receiver flared with multiple fire control locks. The S-400's terrifying gravestone radar burned through Ukrainian jamming with relentless 350-watt pulses, bathing the MiG with enough electromagnetic energy to physically heat its radon gas. He had exactly 90 seconds before entering the S-400's engagement envelope, where the deadly 486E missiles could reach him in just 24 seconds. Timing was everything. Earlier that day, Ukrainian Su-24s had launched a coordinated HARM missile strike on radars near Tomak, temporarily knocking them offline. Electronic warfare units broadcasted false radar returns, drawing defensive attention to Phantom strike packages northwest, while the lone MiG slipped in from an unexpected vector. The pilot leveled out at release altitude with 12 minutes of fuel left for the return journey. The 4 GBU-39 bombs ran final system checks. Their GPS receivers locked onto 5 satellites with a pinpoint 3-meter accuracy. The nearest SA-15 battery was 41 kilometers southwest, just outside its engagement envelope, but close enough to react if he lingered. S-400 radar emissions signaled the battery was preparing to fire, but physics was on the pilot's side. Their missiles would arrive 30 seconds after weapon release, too late to intercept the bombs. The Kushuka 4 continued to jam GPS frequencies, blasting L1 and L2 signals with 500 watts of interference, trying to blind the precision strike. But this was no ordinary weapons system. In 60 seconds, the pilot would find out if American engineers had truly built the GBU-39 to operate in the world's most hostile electronic warfare environment. The fate of thousands of Ukrainian civilians living under constant drone attacks hinged on 37 kilograms of high explosives and the cutting-edge guidance electronics daring to navigate an invisible storm. At 15:28, the pilot released the first GBU-39. The aircraft jolted as 250 pounds peeled away from the starboard pylon. Instantly, the bomb's GPS receiver registered massive interference across all channels. Within 200 milliseconds, its guidance computer detected signal-to-noise ratios below acceptable thresholds and seamlessly switched to inertial navigation mode, an onboard GPS backup immune to jamming. 82 kilometers away, the Kushuka 4 operators remained unaware their jamming had been rendered useless. Seconds later, the pilot released the second bomb from the port pylon, then the third from the center line, followed by the fourth. Each bomb unfolded its wings 2.7 seconds after release, morphing from simple ballistic projectiles into sleek guided gliders capable of 20.1 lift-to-drag ratios. Their onboard computers calculated optimal flight paths to converge on the target from multiple angles, overwhelming defenses by preventing any single-point defense system from engaging all 4 simultaneously. The bombs would glide 89 kilometers through contested airspace, arriving in 30-second intervals to inflict sequential, crippling blows. The pilot immediately rolled the MiG inverted, pulling 5 Gs toward the ground. His radar warning receiver screamed as SA-15 acquisition radars locked on. The nearest battery fired 2 9mm9 missiles at 15:29:15, but their calculations doomed them. Intercepts would arrive 45 seconds after the MiG vanished behind terrain masking. Physics had already sealed the pilot's fate. Missiles would chase a target disappearing into ground clutter, rendering radar guidance useless. Meanwhile, the GBU-39s carved their paths through the sky at 180 meters per second. Each bomb updated its inertial navigation 20 times per second, cross-referencing accelerometer data with hardened pre-programmed waypoints. At 15:31, brief windows of GPS signal broke through the jamming, allowing the bombs to confirm they remained within 8 meters of intended flight paths. Inertial navigation alone had kept them accurate despite flying through the fiercest electronic warfare environment on Earth. At 15:32:44, the first bomb locked onto its target, the assembly building's metal roof, radiating heat uniquely against surrounding structures. The bomb's infrared seeker matched this thermal signature to reference imagery with 94% confidence. Its tail fins adjusted, striking at a precise 68-degree angle for maximum armor penetration. 28 seconds later, the second bomb struck the electronics workshop, home to guidance system programming for Iranian-designed autopilots. Without this facility, drones would be reduced to crude, inaccurate flying bombs. The bomb punched through the reinforced roof, detonating amid delicate circuit boards and programming stations. The resulting overpressure wave and shrapnel shredded remaining equipment, crippling the enemy's drone production capabilities. The third bomb impacted the storage warehouse at 15:33:41. Intelligence reported 15 to 20 completed Shahed 136 drones stored here, each carrying 40 kilograms of explosives. A devastating secondary explosion followed the bomb's detonation, obliterating inventory and crippling the southern sector's entire logistics chain supporting drone operations. Millions of rubles worth of fuel, spare parts, and maintenance equipment vaporized in seconds. The fourth bomb double-tapped remaining structures, sealing the target's fate. For the Kushuka 4 operators, the explosions rocked the facility, proof their jamming had failed spectacularly. Their system, designed to flood GPS signals and send incoming weapons blindly astray, had been outmatched by American engineering tailored to counter Soviet-era electronic warfare tactics. But the mission wasn't over. The MiG pilot now had to survive a gauntlet as Russian forces scrambled to prevent his escape. At 15:34, he leveled off 400 feet above ground, clutching 750 kilograms of fuel. His tactical computer displayed 180 kilometers to Ukrainian airspace, roughly 12 minutes of flight if he maintained optimal speed and settings. Behind him, towering smoke columns climbed 3,000 feet as secondary explosions consumed remaining munitions and fuel supplies, lighting the sky like a war zone bonfire. Suddenly, missile launches lit the radar warning receiver, SA-15 batteries scrambling 9M9 surface-to-air missiles. Accelerating to Mach 2.8, these missiles raced after him, but the pilot remained one step ahead. The valley ahead offered a natural radar shield, a river cutting through ridges, breaking missile lock in 45 seconds. Russian air defense commanders vectored 2 Su-35 fighters from Bryansk to intercept. Their R-77 missiles boasted excellent range, but their radars struggled to track a low-flying, fast-moving target cloaked in ground clutter. The MiG held course, refusing to climb and reveal itself. The Su-35s needed 8 minutes to reach his position, time he used to put 75 kilometers between himself and danger. Crossing the Malakna River at 15:38, the pilot reached the edge of Russian radar coverage, disappearing behind the ridgeline. SA-15 missile locks faded, their weapons self-destructing harmlessly. The Su-35s, low on fuel, abandoned pursuit. Post-mission analysis would reveal critical intelligence. The GBU-39s maintained navigation accuracy within 12 meters, despite non-stop GPS jamming, validating claims about their resilience in electronic warfare. The Kushuka 4 system had performed flawlessly, yet failed to defeat weapons designed with it in mind. More than that, Ukrainian innovation had transformed a 40-year-old MiG-29 into a precision strike platform, a lethal blend of desperate creativity and cutting-edge technology. The mission was a stark reminder. In modern warfare, victory often comes down to who can bend the old rules and outsmart the new threats. For now, the pilot fades into the clouds, but the war is far from over.